Today we're going to solve equations with logs. In order to do that, we need to make sure that we only have one log in the problem. If there are multiple logs, we'll have to use one of our properties that we know in order to condense it into one log. All right, in example 1, we're going to solve this. So if you notice, we only have one log in the problem, and there is nothing in front being multiplied by the log. There's nothing after the entire log being added or subtracted. There's that -5, but it's in parentheses. It's in the log. So when there's one log, what we're going to do is we're going to change it to exponential form. All right, so we practiced this on the very first day that we learned logs. So we find our base, so whatever the base of the log is. So this one has base 8. And then the power was what the log was equal to. So 8 to the 2/3 power equals, and it's whatever the log was of. So x minus 5. So in order to get our answer, in order to solve for x, all we have to do is get x by itself now. So we're going to add 5 to both sides. So x will equal whatever 8 to the 2/3 plus 5 is. Now if we remember 8 to the 2/3, the 3 that's the bottom of the fraction is a cube root. So we have the cube root of 8, which is 2, and 2 squared is 4. So we're going to take 4 and add 5. So our answer is going to be 9. But if we don't remember that 8 to the 2/3 was 4, then we'll use our calculator and do 8 to the 2/3 plus 5. 8 to the 2/3 power, and then plus 5. So we were correct, it was 9. So x equals 9. And we could substitute that in and make sure that it works, right? Make sure the two sides are equal, and it is true. So x equals 9. On the second example, we are going to solve for x again. But if you notice, we do have only one log, but there is a number in front of the log this time. All right, so any numbers that are outside of the log, that are not a part of the log, we need to get rid of first. So the 4 is being multiplied by the log, so the opposite of multiplying is dividing. So we have log of 2x equals, and then I'm going to leave it as 5/4, just like in the previous video. I want to wait to use my calculator until the very end so that I'm not rounding too much, because I don't want to round until the very end of the problem. All right, so I have a single log, so I need to change it to exponential form. Now, I don't see a base there because that's what I need, but remember, when a log does not show a base, when it's not written, the base is 10. So we have 10 to the 5/4 power equals 2x. And to get x by itself, we're going to divide by 2. So x equals, and this time I don't know what 10 to the 5/4 power is because I don't know the 4th root of 10. So I'm going to use my calculator. And I get 8.891. In this third example, notice this time I have more than one log. So I'm going to have to use my properties and condense it into a single log. So I notice between the logs there's a subtraction sign. So back from our properties, the subtraction sign, whatever's being subtracted, goes in the denominator, so they're going to be divided. So I write this as a single log, so log, and I notice it has base 2. And then I'm going to divide whatever the two things that were for the log. So I've got x over x minus 7. And that still equals 3. So I condense those two logs being subtracted into a single log of division. All right, so now that we have a single log, we are going to rewrite it in exponential form. So my base is 2 to the 3rd power equals x over x minus 7. Okay, I'm going to have to solve this. So in order to solve this, I've got a fraction on the right-hand side, and I don't have one on the left side. So I'm going to make them both into fractions, and then I'm going to cross multiply. So first off, 2 to the 3rd, though, is 8. So I'm going to rewrite this as 8/1 equals x over x minus 7, and then we cross multiply. You could actually just multiply both sides by the denominator x minus 7, but you'll get the same next step either way you do it. All right, so when I do 1 times x, I get x equals, and when I do 8 times x minus 7, make sure you distribute, so you get 8x minus 56. So again, where that came from is we did 8 times x minus 7. All right, now we solve for x. So I have an x on both sides, so I'm going to get rid of one of them. So we have negative 7x equals negative 56. Divide both sides by negative 7, and x equals 8. And you can plug it back in and make sure that it gives you a true statement, and it will. All right, in this example, this time, again, we have more than one log, so we have to condense it into one. This time they're being added, so when we write them as a single log with base 6, then we are going to multiply them. Now when I showed I'm multiplying them, the 3 times the x minus 7, I wrote it like this with parentheses, but you could actually distribute it before you write it down and get log base 6 of 3x minus 21. All right, now from here, we are going to rewrite it in exponential form because the log, there's a single log and it's by itself. So my base is 6 to the third power equals 3x minus 21. All right, so to get my answer, get x by itself. So I'm going to add 21 to both sides. So I have to figure out what 6 to the third is. So 6 to the third is 216, and I'm going to add 21 to that and get 237, and that's equal to 3x, right, this canceled. And then last step is to divide by 3, and when I divide by 3, I get that x is 79. So if you notice here, I've taken an example problem and written out the step-by-step instructions so that if you need to use this as you do examples with multiple logs. This, again, example is of subtraction for logs, so notice it had to be combined using division. And then after you rewrite it in exponential form, then we did have to cross multiply to solve.